Welcome to Lesson 54, where the wires finally disappear. In this session, we're stepping into the world of cellular and satellite networking, the technologies powering modern wireless WANs. We'll look at 5G, low Earth orbit constellations like Starlink, and the rise of private cellular, and see how they're converging into a single story about connecting anything, anywhere. Here's the path we'll walk together. We'll start with cellular evolution, tracing how we moved from basic 2G voice all the way to 5G, and glance at what 6G is starting to promise. From there, we'll unpack the three signature 5G use cases: eMBB for raw bandwidth, URLLC for ultra-low latency, and MMT for massive device density. Then we'll shift into private cellular, where CBRS lets enterprises run their own networks. And finally, we'll go orbital, comparing legacy GEO satellites with the LEO revolution that Starlink kicked off. So let's start with that 40-year arc. Each cellular generation has roughly delivered a tenfold jump in throughput, from 1G's analog voice in the 80s to 2G adding digital voice and SMS, 3G bringing real mobile internet, 4G turning the network all IP with LTE broadband, and 5G pushing us into multi-gigabit territory with millisecond latency. By around 2030, 6G aims for 100 plus Gbps using terahertz spectrum and tight satellite integration. And the recipe behind every leap is the same: wider spectrum, smarter modulation like QM, more MIMO antennas, smaller cells, and denser deployment. Now here's where 5G genuinely breaks from its predecessors. It's not just faster 4G, it's really three networks in one. eMBB, enhanced mobile broadband, is what you feel on your phone. 1 to 10 gigabit peaks for 4K streaming, cloud gaming, and AR. URLLC, ultra-reliable low latency communications, targets sub-millisecond response with 5 nines reliability. Think autonomous vehicles, factory robots, even remote surgery. And MMTC, massive machine-type communications, scales to 1 million low-power devices per square kilometer for IoT sensors, smart meters, and smart cities. One radio standard, 3 very different missions. To deliver those 3 missions, 5G splits cleanly into 2 halves. On the radio side, the RAN, built around the GNB, or G-Node B base station, uses massive MIMO with dozens of antenna elements, beamforming to aim energy at specific users, and slicing to carve virtual networks out of the same airwaves. On the other side sits the 5G core, where functions like AMF for mobility, SMF for sessions, UPF for data forwarding, and UDM for subscriber info each run as independent microservices. That's the service-based architecture, cloud-native, containerized, talking over REST APIs, replacing the monolithic 4G EPC entirely. And here's where 5G gets really interesting for the enterprise. You don't actually need a carrier anymore. A factory, a mine, a port can run its own private 4G or 5G network on dedicated spectrum because Wi-Fi simply can't cover a sprawling outdoor site, and roaming handoffs between access points break the moment a robot starts moving. Regulators have opened the door. CBRS at 3.5 gigahertz in the US, the 3.7 to 3.8 band in Europe, Germany's industrial 5G allocation, even unlicensed NRU. That's why you now see private cellular powering automated factories, autonomous mining trucks, container cranes, hospital campuses, oil platforms, and tactical military networks, all with local breakout. So the data never leaves the premises. Now let's leave the ground entirely and look at the other half of wireless WAN: satellite. There are 3 orbital classes, and altitude is the variable that drives everything else. Geostationary birds sit way out at 35,786 kilometers. One satellite covers a third of the planet, but you pay for it with 600 milliseconds of round-trip latency, which is why GEO is legacy maritime and aviation territory. Medium Earth orbit sits in between, mostly used for GPS, Galileo, and SES-03B enterprise backup. The real revolution is low Earth orbit, Starlink, OneWeb, and Amazon's Kuiper, flying at just 400 to 2,000 kilometers, delivering 20 to 50 millisecond latency that finally feels like real internet. The trade-off: you need thousands of satellites and constant handoffs to make it work. Starlink is the one everyone knows, and the numbers explain why. SpaceX has over 6,000 satellites flying at just 540 to 570 kilometers. That's very low even by LEO standards, delivering 20 to 40 millisecond latency and 100 to 300 megabits down to a phased array dish that costs around €500. But Starlink isn't alone. OneWeb, now under Eutelsat, focuses on enterprise and government with about 650 satellites. Amazon's Kuiper is rolling out through 2026 and will plug straight into AWS. Telesat Lightspeed targets carrier backhaul, and China is building its own 13,000 satellite constellation to serve belt and road regions. The SAM is genuinely getting crowded. So, with all these options on the table, how do you actually choose? Think in 4 dimensions: latency, cost, coverage, and mobility. Public 4G is cheap and mobile, perfect for vehicles and IoT. Public 5G adds the low latency you need for URLC, the ultra-reliable low-latency communications. Private 5G goes under 10 milliseconds, but it's site-bound and expensive, so reserve it for factories and ports. 5G fixed wireless and Starlink land in the same sweet spot for branch backup, while GEO satellite stays in the corner for maritime broadcast or last resort fallback. The modern pattern most enterprises land on is a hybrid: fiber primary, 5G FWA secondary, Starlink tertiary, with sd-wan bonding all 3. That hybrid pattern shows up in very specific places, so let's ground it in real deployments you'll actually see in the field by 2026. Retail chains, banks, and franchises use 5G or Starlink as automatic failover when fiber drops. Field services, ambulances, and public safety run cellular routers right in the vehicle. Construction sites, festivals, and disaster zones spin up pop-up connectivity in hours instead of weeks. Factories, ports, and mines lean on private 5G, where Wi-Fi simply can't handle the mobility or interference. Ships and aircraft ride Starlink maritime and aviation, and remote oil, agriculture, and forestry sites finally get real bandwidth, where fiber will never reach. Now, before you roll any of that out, let's talk about the traps that quietly drain budgets and on-call hours. Cellular Unlimited almost always throttles after some hidden cap, so read the fine print and alert on usage thresholds before a single bad month costs you thousands. Never put interactive traffic on GEO satellite. That 600 millisecond round trip kills SSH and voice. Reserve GEO for one-way broadcast and use LEO when humans are in the loop. Don't trust carrier coverage maps either. Test on site because indoor 5G is spotty and M-Wave needs line of sight. And finally, avoid single points of failure. Dual SIM with eSIM for cellular, and always pair Starlink with a cellular backup because vendor diversity is what keeps the branch online when a mega constellation hiccups. So let's compress this whole stage into 5 anchors you can carry forward. 1. Cellular evolves roughly 1 generation per decade. Voice, SMS, mobile data, broadband, slicing, and 6G around 2030. 2. 5G isn't one thing. It's 3 lanes, eMBB for consumers, URLLC for industrial control, and MMTC for massive IoT. 3. Private 5G lets enterprises own their own spectrum through CBRS in the US or local licenses in Europe. 4. Satellite orbits trade altitude for latency, and LEO at 30 milliseconds is what finally made space-based internet feel real. And 5. Starlink and its competitors turned satellite from a grudging last resort into a genuine anywhere connectivity option. And to make all of that stick, here's your reference card for Lesson 54. Keep this within reach. The speed and latency ranges for 4G and 5G, the 3 5G service classes, eMBB, URLLC, and MMTC, the terminology shift from eNode B to GNB, and the new service-based 5G core, plus the enterprise side with private 5G and CBRs. And at the bottom, the satellite anchor, A single GeoBird at 35,000 kilometers covers a third of the Earth, but pays for it with 600 milliseconds of latency. Screenshot this one. That wraps Lesson 54, but the real test is next. Lesson 55 is your Stage 7 capstone, where you'll work a genuine architecture ticket that fuses wireless and WAN, picking the right access technology, sizing the link, and defending your design choices. Bring everything we've covered, 5G, LEO, CBRS, latency budgets, and put it to work. I'll see you there. Dargslan.com and on YouTube at Dargslan. Let's build.